Section 2. What is binary search and what is merge sort? But before that, what is recursion? If you don't understand recursion, read this sentence again. Sorry for that. But that's what recursion simply is in its true essence. It is when a function calls itself. Like suppose you want to create a function fact of x for finding factorials. And you know that factorial of any number n is equal to n into factorial of n minus 1. So in other words, you can say fact n is equal to n into fact n minus 1. That, my friend, is recursion. To convert it into a recursive Python function, you can write this. Just wrap it into a syntax, because that's what programming language is. A wrapper, a syntactical wrapper for logic, so that the computer can understand it. Now, we can try running it to check how it runs and is it really true. So factorial of n, we can say factorial of 5. So what will happen if we call it with 5? We see 5 equal to 1. Nah. So we will return 5 into factorial of 5 minus 1, which is 4. So 4 is equal to 1. Nah. So we return 4 into factorial of 4 minus 1, which is 3. 3 is equal to 1. Nah. So we do 3 into factorial of 3 minus 1, which is 2. 2 is equal to 1. Nah. So we do 2 into factorial of 2 minus 1, which is 1. 1 is equal to 1. Yep, 1 is equal to 1. This condition will be satisfied. So we will return 1. Now what will this be? 5 into 4 into 3 into 2 into 1, which is 120, right? 5 4s are 20, 23s are 60, 62s are 120, 121 is 120. Okay, so this is recursion. To find a factorial of n, you said that, okay, just find a factorial of n minus 1. Then I'll tell a factorial of n. And then you kept calling it. It can be thought like, to do a task for some input, you will first have to do it with a different input, usually a smaller input, and then the result of that will lead you towards your final answer. Alright, you understood recursion, but now what is binary search? Let me explain it for you. So you have used binary search a lot of times in your life maybe, but you just don't know that it is called binary search. I'll give you an example first, an easy example, kind of relatable one, and then you'll be able to understand the code very easily. So let's say a company came to your college for giving out internships, and then it sorted the selected students according to their roll number. So let's say this is the list index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 or 10. Okay, now this is the list of all the roll numbers that were selected. Let's say it was 114, 210, 300, 304, 315, 500, 550, 600, 610, 620 and 1002. Alright, now let's say you want to see if your registration number is there or not, which means that you are selected for the internship or not. So in that case, let's say that your registration number is 550. You want to see 550 is there or not. So there are two methods generally of searching. One is linear search, one is binary search. Linear search is you go to each of them and see if it's a target or not. Suppose you want to find 550. So you see, is this equal to 550? And the answer will be no. Then you check, is this equal to 550? The answer will be no. Then you check, is this equal to 550? The answer will be no. And you keep going till you find 550 or you run out of numbers. Alright. This is what linear search does. Now, what is binary search? 1 minute. I'll erase all of this so it will be easier for you to understand it in a cleaner slate. Alright. So instead of going to all of them one by one, in the binary search, we approach the problem like this. We say that there's a starting point, which is the lowest point, and this is the ending point, which is high. Okay, so you have to find your number 550 in this entire range. So let's say this is the midpoint then. Now you see, is this your number? Is this 550? So the answer is no. Then you see, is it smaller than 550 or is it greater than 550? So this says that this is smaller than 550, which means 550 will come after this. So you can neglect this entire part and start searching from here. Okay, then you go, this is lowest, this is highest, so this will be the mid. Okay, this is 610. So you check 610 is equal to 550. The answer will be no. Now 610, is it bigger or smaller? 610 is bigger, which means 550 should be before 610. So you can neglect everything after 610. Okay, and start from here. H. Now you can see the midpoint, which is in two elements, whichever one you can choose will be the midpoint. So this will be the midpoint. 550 is equal to 550. So you have found it in only 3 steps. You got it? You, instead of searching everyone one by one, you just go to the middle and see if it's greater, equal or less. If it's equal, you found it. If it's greater, which means that you have exceeded it. So no need to find after this, find before this. If it's smaller, then no need to find before this, find after this. Okay. I hope it was very easy to understand now. Now I'll tell you the code and you'll get it hopefully. All right, so let me try. Suppose, okay, this was the program. You have to search. This is the function search. You are given an array or a list, then your target, your low, and your high. Okay, the low initially is the 0th element, high is the last element. So what's the base case? If low is greater than high, if your initial element has crossed your final element, suppose you started like this, and then you shifted this here, then you shifted this here, then you shifted this here, then you shifted this here. Now, when your low and high have crossed, which means that your starting point has exceeded your ending point, which means you have traversed the entire list, the entire array, and it did not find it. So when your starting point exceeds your ending point, it means that the element was not found, and you can say return -1, not found. Otherwise, what did we do? We found the midpoint, which is low plus high by 2. Then if the element, the midpoint element, is equal to target, then you return mid. Otherwise, you check else if or elif for Python, that is the midpoint element greater than target. If it's greater than target, which means that you don't have to go any further, it was before this. So you will search in the array for the same target with the same starting position, but the ending position will not be the last. It will be just before the midpoint, because your midpoint is bigger than your target. So you can stop your searching at mid -1. Otherwise, if your array of mid, if your midpoint element is less than target, then you don't need to search before this, you have to search from after that, which means you can search the array for t, and instead of searching from the start, you can start from the midpoint. You start to search from midpoint. So mid +1, comma h. This is it. That's all. Okay. So instead of searching everything, you divide and search, divide and search, divide and search. I hope you got it. Now let's move further, and you'll understand it even more. So, yep, next slide. Example usage. Well, it's easy. It's the most basic example that I can give, and the numbers are very trivial. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and these are the indices. Okay, so suppose your target is 7. Then how do you call the function? You say that in the array, like search in the array, search for 7, start from 0 and end at 9. Okay, so what do you do? From 0 to 9, you search, you go to the midpoint, which is this one. Then you see 5 is smaller than 7, right? So you don't need to search before this. This was L, this was H. I'll change the pen color. It'll be easier for you to understand. 1 second. Yeah. So this was L, this was H, this is the midpoint. So you checked 5 is smaller than 7. So which means you can neglect everything from here and you can start searching here. Which means that this will call this search array, in the array 7, and instead of starting from 0, start from 6 and end at 9, 9th index. Okay. Then again 6 to 9. Now we check what is the midpoint. This is the midpoint. So is 8 smaller or greater? 8 is greater than 7. So you can neglect everything after 8 and search before 8. So you can say that search in the array, search for 7. The starting point is same, ending point is 7. So depending on how you see, if you take the floor value, you'll run one more time, and if you take the ceiling value, you'll just stop there. Because if there are only 2 elements, then it depends on you how to choose the midpoint. So this is it. Okay, you got it? I hope. And I'll write it again in the slides if you want to see. So we understood what is binary search. Now let's see when to use binary search, or why is binary search. I hope someone got the reference. So moving on, when to use binary search. Now you may have noticed that in all the examples that we took till now, the data was sorted. Okay, you had registration numbers sorted. The previous example, everything was sorted, so that you can go to the midpoint and then see if you want to go before this or after this, just by seeing the midpoint. Like in a dictionary, suppose you want to find a word in the dictionary, then you won't start from the very start and search A, B, A, C, A, D, A, E like that. Suppose you want to find elephant, then you won't search like that. How will you search? Suppose you want to find elephant and then you open the dictionary, you land up on lion. Now you know that lion comes after elephant because lion is bigger than elephant alphabetically. So you say that, okay, everything after lion I can ignore. I need to search before lion. So you open it again before lion. Now you see that your search data has become half. You have to search in the entire direction. Now you have to search just before lion. Now you open and you see, okay, giraffe. Giraffe comes after elephant. So I can ignore everything after this and I have to search from start to giraffe. Then you open it and you find elephant. So it becomes so much easier. Instead of checking each word, you just half it, and see if it's bigger or smaller. Alright, you got it? You continue this process, narrowing down your search each time until you find the page with elephant. This is how binary search works. It's like dividing and conquering, making your search much faster compared to checking each page one by one. This is an image for the reference on the right. Please ignore the bird at the top because the question is about giraffe, lion, and elephant. Okay, now when not to use binary search? In cases where data is not sorted. Okay, in most real life cases, either if you want to use binary search, you sort the data and then use binary search, or use linear search. This is an example of when you cannot use binary search, like finding a needle in the hay, because it's just unsorted data and you cannot find it. For binary search, you need to find a pattern, and pattern only comes when it's sorted, right? Because okay, now not this, then half of this, then half of this. Alright, the physical activity. Enough of the theory. Since you are the ones chosen to have a physical experience of recursion, let's get started with it. Excited? I hope. Again. Alright, the people's BS, binary search. I thought of the name jitters and choosers before this, but then I was like, nah, I can do worse. Anyways, let's say there are 15 students in your team. So we will divide them into two groups of 7 and 8. The groups may parallelly play the game in order to save time. Now let's see what happens of the time, because we don't know the exact dates and everything. So let's take the group having 7 people, for example. From the 7, there will be 1 chooser and 6 jitters. Okay, from the 7, 1 chooser, 6 jitters. There will be 7 rounds, and in each round there will be a different chooser, so that everyone can get the chance to be a chooser. Alright. So in each round, the 6 jitters will pick up 6 big chits of paper. Like this. Okay, they will pick up a big chit of paper with a number written on it and arrange themselves according to that number. The chit, I should write it on it. What should I write? Let's say 7 and 73. Okay, I hope it's visible. So the chitter will have, all the chitters will have their chits in the left hand such that the number is not visible to the chooser who is standing in front of them. So they will keep it like this. Now they can see the number, but the chooser cannot see the number, and they are standing next to each other in an ascending or descending manner depending on where you look it from. Okay, so the chooser is looking at all the jitters, and the jitters have a chit in their hand such that the chooser cannot see the number. Easy. I broke it down as much as I could. Okay, now since the chooser has to follow the binary search, then I'll just read it. Okay, the chit will be held in each chitter's left hand such that the number is not visible to the chooser unless the chooser chooses them. The chooser will have to choose the chitter, then the chitter will flip the chit and reveal the number. The chooser will have 3 labels, L, mid and H, representing the start, mid and end variable of the binary search. Just like binary search in each iteration, the chooser will have to reassign the labels by putting it in the right hand of the respective chitter. Okay, so each chitter will have a chit in the left, and then chooser will choose that whom should he give. Let's suppose this is a label. Whom should he give the label of L, mid and H after each iteration. Okay, got it? It's easy. The chooser will choose the mid person, and then the mid person will reveal the number. Then the chooser will decide whether to go left or right depending on if it's greater or smaller than the target. The chooser will be given a target. Okay, simple, easy, got it. If you still have any doubts, ask me or ask us, any of us. Okay, just don't get overwhelmed. It's easy. Just try. Okay, and there was also another section of merge sort you might have noticed, but I was thinking it was getting too much for you. Too big, completely new algorithms and tasks in just one section. So we decided to remove it. You can thank me, thank us in the comments. I don't know what's going to do that. And just have fun. Now there is less syllabus for you. So pay attention to it and don't cheat. Be honest. And I mean, there is not much scope of cheating in this, but still. Have fun and involve yourself and learn. Alright? See ya. End of section. Bye-bye.